the battery is low. Join. Okay, I'm gonna let that charge for a bit. Testing, testing. Okay, that looks that. Go with that. All right. Let's do another thing. Loaded. Just about ready to get started. Give me just a few more moments. Don't let that one ride. All right. All right, scholars. Hopefully you are ready for today, right? Now, so I think, on Wednesdays we usually do a homework session. And so I like the notion of when we do our, polls, I like to make you accountable for that. When it wasn't accountable, it wasn't really getting that much engagement. So now I'm going to make you accountable, right? So I think last time, I don't know if you all had that opportunity or not, but the way it goes, when I make the polls active, whatever question number we're on, you just want to highlight that. We're not going to submit it until about like 9:30, right? Because I want to take some time to like assess it and give you all feedback, right? So we'll stop with the homework around 9:30, and so essentially we're gonna run it like our normal homework sessions, but as far as those poll the audience, you need to earn at least 50% credit to get attendance. All right, so when I'm doing those, you not only want to submit an answer, but you want to try to get it right. If you get it wrong, then you're just wasting your time. But you get it right, you need to earn at least 50% correct at the end of class to get attendance credit. Right, so it's not wholly passive. As always, if you have questions, feel free to either unmute yourself or type in the chat or the Q&A. Submit it either in the chat or the Q&A, and we can make sure to get it addressed. And also be sure that you all are working on the lab with Dr. Lamar. Right, so. Yeah, so that's the meat and potatoes. Okay, so let's kind of get into it. So I already did my give me a random number. So we'll start with question 3. Ooh. Let's start off with question 3. Everyone is doing well. Let's suppress this and let's zoom in just a bit. All right, that looks decent. So for the following polynomial function, find the degree, the leading term, and the leading coefficient. I like how we did it during class for the multiple choice, but I think I'm just gonna, for the sake of time, I'm just gonna do this one. Let's see. So find the degree, right? The degree of a polynomial is going to be the highest power on any term. All right. Yeah, I'll just do it. So the degree in this case is going to be 4. Hopefully we're thinking 4. Actually, I'd like to use, I'm going to turn this off. I'm going to use this guy here. All right. Okay. So let's submit 4 there. The leading term. So the leading term is the term with the highest power. So in this case, that's going to be the pi over 3 x to the power of 4. That's our leading term. Sometimes, they have them jumbled up. So as you work these examples, it's a good idea to put them in descending power order. This one is not in descending power order, but we just got lucky that the leading term just happened to come first in this example. Let's see if I do pi. I think that worked. Be nice to see this. There we go. All right, let me zoom out. I think that's why I can't see. Pi over 3x to the power of 4. That looks decent. Okay. And the leading coefficient is the coefficient of the leading term, so the number in front of the leading term. So in this instance, that's pi over 3. Okay. A random number. Let's go to question 13. So question 13, we can find it. Sure. All right. So for this polynomial function, find each real zero. Okay. I'll do this one just because it's not multiple choice. So we got lucky with this one because it's already in factored form, right? So we don't have to factor it. So then we set each factor to 0 and solve, and we'll get -7 and 5. So we'll say -7, 5. Okay. And then state whether the graph crosses or touch, but does not cross the x-axis at each x-intercept. So this is a question of multiplicity. So the multiplicity of 5, when we look at the multiplicity of 5 is 3 because it's to the power of 3. So which is an odd number, which means it crosses. So the multiplicity of 5 is 3, okay? And the multiplicity of 7 is 2. Oh, that's not 2. Okay. So at 5, because 5 has an odd multiplicity, it's going to cross the x-axis at the x-intercept. And since the -7 has the multiplicity is 2, which is even, that means the graph is going to bounce off the x-axis. So it's just going to touch the x-axis and go the other direction. Okay. The maximum number of turning points. When it comes to like the max number of turning points and the max number of zeros, I like to visualize a quadratic. I know that the degree of a quadratic is 2. I know for quadratics, we have at most 1 turning point. So then let me see. So if we were to expand this guy, this would be to the power of 5. So that means we would have at most 4 turning points. It's n-1, right? So we have at most 4 turning points. Okay, not too bad. All right, let's generate. Let's go to question 10. 13, 12, 11, 10. Oh, okay. All right. So, moment of truth. Right. So again, with these submitted in about 20 minutes. So let me go ahead and launch the poll. And again, this is for attendance credit. If you don't earn 50%, then you're at my mercy. And it's based on how I feel. It's based on my mood. If I'm not in a good mood, then you're gonna suffer. If I'm in a good mood, then I might be lax. It just depends, right? That's if you fall below 50%. If you're above 50%, then you don't have to deal with that. So you want to go to question 10. All right. Let me see. Let me zoom out some so you guys can see. Let's do one more. Like this. Okay. So there is an active poll. Okay, there we go. I know that the equation might be a little bit difficult to see, but I just kind of do your best. But I did want you to be able to see those. Let's take a. We'll go up until like a full minute from now. So 1 minute and 30 seconds. So just take a moment and see if you can answer this. This one asks us to match the following polynomial function with the graph. Okay. So let's go to 2 minutes. I want to give you a little bit of time on this to see if you can get it. On your end, you just want to highlight the correct answer. Don't submit the quiz yet because we're not going to submit it until the 30-minute mark. Okay, so you still have another minute. Let me look at it myself. Let me see. Okay. Okay. Let's see. Okay. All right, I got my answer. So again, we're just highlighting our answer. So you want to go to question 10 and highlight your answer in question 10. I'm feeling like it is this one. Okay. And again, we're not going to submit it until, so we're not going to see any feedback until we submit this in about 15 minutes or so. Okay. Let me see my timer. I'll give you another 20 seconds to highlight this one, and we're going to come back to this. We'll come back to this one. So maybe you need to screenshot it 15 seconds. Since while we're waiting, we get a little bit of 5, 4, 3, 2. It's time. All right, that's enough. Okay, so again, we'll submit this a little bit later. We're going to come back to this one. That was question 10. Okay, so generate. We'll go to question 5. 3, 4, 5. Okay. All right, so another multiple choice. So then let's see. So it says determine if the following function is a polynomial. If you think yes, it's a polynomial, you will put A for question number 5. If you think it's not a polynomial, you will put B. All right, so we'll take maybe 20 seconds, just long enough for me to submit it, really. So this is question 5, okay? Okay. So question 5, you just want to highlight your answer. Okay. Again, if you think this is a polynomial, you will highlight A. If you think this is not a polynomial, you will highlight B. Okay. All right. We're gonna let that be. We're gonna come back to that one in about 15 minutes. I know I said 15 minutes 5 minutes ago, but that's what it is. All right. Let's go to question 12. Which one was this? I think that was 13. All right, 12. Okay. So for the polynomial function below, list the zeros and the multiplicity, determine whether the graph, okay. So the zeros, okay, so we got lucky with this one because it's already in factored form. I'll zoom in like this, okay. We got lucky because it's already in factored form. So then to find the zeros, once we get it in factored form, then we set each factor to 0 and solve. And so when we do that, we'll get -2 and 4 in this case. So then -2, 4. And I think I'm just going to go with that. Okay. What is the multiplicity of 4? So when we look at the original function, the factor, the multiplicity of 4 is going to be a 1 because it's that factor is raised to the power of 1. So that multiplicity is 1. Okay. What is the multiplicity of -2? That multiplicity is 2 because of the power. Okay. So at 4, because it has an odd multiplicity, it's going to cross the x-axis. At -2, because it has an even multiplicity, it's going to bounce off the x-axis or touch and turn around. Okay. Not too bad. Let's generate. We'll go ahead and do question 2. Number 2. Okay, for the following polynomial function, find the degree, the leading term, and the leading coefficient. We should rewrite this so that it has real coefficients. You know, it doesn't really look like a polynomial the way it's written. But because we're dividing by a monomial, we can distribute. Dividing by 5 like that is the same as distributing 1/5. So the degree is the highest power. In this case, that's going to be a 7. Okay. The leading term is the term with the highest power. So again, we need to distribute that 1/5. So then that way the leading term takes on the form 3/5 x to the power of 7. Okay. The leading coefficient is going to be 3/5. It's the coefficient of the leading term. So in this case, it's going to be 3/5. Okay. We're moving and grooving. Now, if we finish early, then we finish early. You know, we'll have a great weekend. If we just happen to finish early. We still got 10 minutes. I think that was 17, 16. Okay, that's fine. Let's see, 20, 19, 18, 17, 16. Okay. Use the intermediate volume theorem to check whether the polynomial function given below has a real, should be 0 in the interval, the closed interval from 1 to 2. If it has a 0 in the interval, approximate the 0 to 2 decimal places. Okay, so for this one, what I'm going to do, I'm going to use my trusty dusty rusty calculator, right? And what I'm going to do, come on. There it is. There it is. We're going to suppress that for right now. We're working here. Yes. Okay. Reload and refresh. Okay. So what I'm going to do, I'm going to use my TI-83 plus, and I'm going to put the polynomial into my equation editor, my y equals. We have 2x to the power 5 minus x squared minus 12. Okay. And then, so the intermediate volume theorem states that, like, if we have one x is strictly less than another, and then f of the first x has one sign and f of the second x has a different sign, then there has to be a third x between the first two such that f of that third x equals 0, right? In other words, because polynomials are continuous smooth curves, and if two different x values have opposite signs in our y value, somewhere between those x values, it has to cross the x-axis, using that property that polynomials are continuous, right? Okay, so what we're going to do here is evaluate this polynomial at those endpoints and verify that we have a change in sign. So what I'm going to do, I'm actually just going to pull up the table. I'm going to go to table set, and I want the table to start at 1 and change by 0.1. So that way we'll see 1, 1.1, 1.2, all the way to 2, right? So now I'm going to just hit enter. I want to go to the table, so I'm going to hit second graph to access the table. So we can see that when x is 1, we get negative 11. And when x is 2, we get 48, right? So we have our change in sign. We went from a negative to a positive. So somewhere between 1 and 2, it has to cross the x-axis, right? The approximate 0 to 2 decimal places. Okay, so now the reason we're using the table, because we can see down to the 10th, we see that the 0 is somewhere between 1.4 and 1.5, right? Because that's where we get our sign change. So now I'm going to go back to table set. I'm going to have the table start at 1.4, and now I wanted to change by 0.01. So we're like zooming in. So now it's going to show us 1.4, 1.41, 1.42, 1.43 until we get to 1.5, right? So now when I go back to the table, starts at 1.4, okay? And we want to kind of go down until we see our sign change. Boom, right there. So between 1.47 and 1.48, we get a sign change. So we need to go back to the table set and zoom in again. Right. I think right now we're at the level of hundreds. Now we want to zoom into the thousands. All right. So 1.47, stat table set, start at 1.47. And I wanted to change by 0.001. So we're kind of doing that whole Ant-Man thing where we're zooming in to the specified whatever, right? Okay. So now we're trying to find the 0 between 1.47 and 1.48. Okay, so we're checking our signs. We get a sign change right there. So the 0 is somewhere between 1.479 and 1.480, right? If we round to 2 decimal places, both of those round to 1.48. So then the approximate 0 of this polynomial is going to be 1.48. Okay, 1.48. Okay, so I'm not sure if you've ever come across that technique or not. I'm pretty sure I did it in my recordings. If you didn't see it there, you may have discovered it when you were going through the homework. If not, hopefully it registered and you can use that. All right, okay. We got time for a few more. generate. I think we did 10. Let me check over here. Okay, we've done 10, so we'll go ahead and look at 11. I think this is 11. Okay. So we haven't had too many multiple choice, so we're gonna see how it works. Match the polynomial function with the graph. Okay, so what's the y-intercept, right? So again, I think we mentioned that, you know, if we're gonna graph a polynomial, one of the first concepts to explore are intercepts. And my recommendation, if we're gonna do intercepts, to start with the y-intercept, all right? Because all you do is set x to 0, and you see if you set x to 0, those first three terms disappear, and you're only left with the constant term, which you can just look at and get the answer. You get 13, right? So the y-intercept should be 13. Okay. So that's why I like to start with the y-intercept, because oftentimes it's just that easy. Ooh, okay. All right. You know what? I think that I will like to do the multiple choice with this one. So this is question 13. Okay. I want to give you at least a minute. So we'll go until I see 13:30 on the clock. Okay. So you want to go to question number 11 and try to highlight which one you think is correct. Let me see. Okay. Oh, okay. Okay. So you want to go to question number 11 and highlight which one you think is the answer. We still have a solid 5 minutes before 9:30. So we're going to come back to this one. I'm going to kind of leave it for now because I'm going to close the poll, and then we're going to see what are the correct answers for the multiple choice that we've done. We just did that one. So we'll just do the next in the progression. We're going to come back to 11. So there's 12, 13. So we'll do 14. Yeah, that's fine. Are you sure you want to leave? Yes. Okay. Determine the zeros of the polynomial and its multiplicities. Let me see. It almost looks like it's factored. Can that trinomial be factored? Let's see. Can we find two numbers that multiply to give us -5 and add to give us a 1? I don't think so. All right, because the only factors of -5 are -1 and 5, and those add up to either 4 or -4. So I feel like that's completely factored. Okay, the real zeros. If we did the quadratic formula, let me see, -1 plus or minus the square root of b squared minus 4 times a times c. Okay, so we might need to do the quadratic formula there. I think I'm avoiding it, but we might need to take some notes. Okay, let me take some notes here. Okay, so if I'm going to do the quadratic formula, the negative boys, so that would be -1 plus or minus. What if I just do plus or minus? No. If I do plus or minus? No. If I do plus or minus? Darn it, nothing works. Oh, come on. Now let's on the tantrum. Get rid of that. Back here. All right, plus or minus. Okay. The negative boy couldn't decide, so square root. The negative boy couldn't decide to go to the radical house because, so b squared is going to be a 1 because he was square and he missed out. So minus 4 times a times c, so 4 times a -5. Okay, all over 2a, so divided by 2. Okay. So then double negative is positive. That's 1 plus 20, which is the square root of 21. Use commas to separate answer. Use integers or fractions. Type an exact answer using radicals as needed. Okay. Okay, so we need the radical. Okay. So -4 times -5 is a positive 20. So I'm going to change this. Actually, 20 plus 1 is going to be 21. And that's going to be as exact as we can get it because the only factors there are 7 and 3, so it's no perfect squares. So those are two of our zeros. And then we have the x to the power of 4. That one is going to be 0. So we're going to say 0, comma these. Okay. So we got these 3 zeros. Okay. We're going to go with this. Cross our fingers. God is good. Okay. The multiplicity of the 0 located furthest to the left. So that's going to be the -1 minus the square root. That's going to be the far left one. That multiplicity is 1. Okay. The middle multiplicity, so that's going to be our 0, is to the power of 4. So that multiplicity is going to be a 4. All right, this is going to have to be the last one. The multiplicity of the 0 located to the furthest right. That was also going to be a 1. Okay. All right. So the leftmost, because the multiplicity is odd, is going to cross the x-axis. Okay. Because the middle is even, has an even multiplicity, is going to bounce or touch. And the far right is going to cross. Okay. All right. So we need to wrap this up. Okay. So that's close enough. Let me see what the next one is. If the next was multiple choice, I'll use it. If not, I'm going to skip it. Let's go to question 15. That was 14. Let's look at 15. If it's multiple choice, then we'll use it. Okay. So this is a kind of a repeat of the other one. I'm gonna let that be for now. So we're close enough to 9:30. I want to go ahead and close the poll and assess what we've done. Okay. So, all right. So the way we submit the poll, so we're gonna go ahead and submit our results for feedback. And again, you need to earn at least 50% correct in order to get attendance grade. If you don't earn 50% correct, then you're at my mercy. It depends on how I feel. Okay, so at the bottom, right, we have to go down to the last 2 questions. Are we in the last 10 minutes of class? You want to put, just say yes, and then do your rating on your confidence level. If you're not confident, you will put a 0 for dear Lord, dear baby Jesus, I need some help. Or if you're confident, they don't have it. You will put 10, like SpongeBob. If you're ready, you put 10. So take, we'll take about 45 seconds to allow people the opportunity to submit that. We got a full house. We got 19 people here. So, again, this is how we get our attendance graded for today. So I'll give you we got another 30 seconds. If you're missing from this.
Excuse me.
Go ahead.
I can't submit the quiz without selecting everything. Selecting every question.
Just at the bottom. Just the last 2
okay.
questions. Yeah, just the last 2 questions.
My bad.
Yeah. Also, I'm not able to see the poll anymore. Like, it just disappeared from my screen.
Yeah, I don't know. So you should be able to access it because it's still open.
Okay, yeah, never mind. I just found it again.
Okay.
I'm sorry about that.
You good. So we got about 7 out of 19. That's a lot of people that's not going to get attendance today. Let me give you some more time because I don't want to do that to that many people, but I will. So, I don't want to have to do that. I only do that because the engagement is low. Let's give it another a few more. Let's give it about 30 more seconds. This is for attendance, okay? So if you're not submitting, if you're MIA, to me that says you're not here. All right. Let me hit submit. We got another just about 30 seconds. We're doing pretty good. We're missing 9 people. Where are these people? Are you guys here? Are you trying to get attendance? Or do you want to just give your money away? If you want to just give your money away, you can just give it to me directly. If you just want to throw money away and not get credit for anything, you could just give it to me. It's not going to change anything as far as grading, but if you're just giving out money, I will gladly take it. I'm not going to turn it away because by not doing this, that's essentially what you're doing. Oh my goodness, we're there. Okay, I'm about to close this. It's at least 9 people that's MIA. Oh my God, that's a lot of people. It's not going to. Oh, okay, somebody's there. Couple more. We got 8 more. I really don't know what to do it, but again, I am a man of my word. I'm going to mark you as absent. So, okay. All right. I'm assuming these guys are not here. Oh, there's another one. Okay. If you keep trickling, I'm going to wait. Give you a little bit of time because I don't want to slack you. These are easy points. There may be some other opportunities if you can get, depending on how well you guys do. We can shift gears instead of it being negative. It can be constructive. All right. I still got 7 people. All right. I think that's time. I don't think they care. All right. So to me, that says they just logged in and they're asleep or something. So going once, going twice, Forever hold your peace and rights. Oh my goodness, we're gonna get a lot of absent people today. Oh, can we get one more? Oh, okay, we got one more. That's good enough. Okay. All right, poll is closed. All right, all right. So I'm gonna go ahead and share the results. Okay. So now we need to go back and check some of this, right? Because I know some of them we skipped. Let me see. All right, so it's just the ones that I answered. I know somebody was trying to answer all of them. You didn't have to answer all the questions. It was just the questions at the end. So I'm just gonna go to the ones that I answered. All right, so the first one is question number 5, right? So we can ignore all those others. So if we go to question 5, it's 3, 4, 5 is this one. So for 5, if we review this one, is this a polynomial function, right? For polynomial functions, they have to be a finite sum of monomials. If we distribute the x squared, we do not get a finite sum of monomials because of that -2 divided by x squared. That's going to be a x to the power of a -2. The powers on any term have to be non-negative integers, right? So a negative integer means that we're not working with a polynomial. So this one should be b, right? So if you answer anything other than b, you don't get credit, right? The only getting credit on question number 5 is b. So we're gonna, that one should be that one, okay? So that's that one. So I can see the stats. You only get credit if it's correct, okay? The next one is, let's go to question 10, right? That was the other one that we did. So that's 5, 6, 7, 8, 9, 10 was this one. Okay, so for 10, it says match the polynomial with the graph. So we can use the leading term test here and do process of elimination, right? We can do the leading term test. You don't have to answer all the questions, again, just the ones that we worked on together, and then submit the last two at the end. I made the last two required because, anyway, we can talk about all that later. I'm trying to wrap this up. Let's see. So if we did the leading term test, right? The leading coefficient is positive, so that means our graph should go up to the right. So that automatically eliminates A and B, right? So it can't be A, it can't be B, okay? And then the degree of the polynomial is an even number, so that means the other side does the exact same thing. So we should go up to the right, up to the left. So C and D both do that, so that doesn't help us. So then we can use the y-intercept, right? The y-intercept should be a 5, and it looks like that's C. So for number 10, I think I did choose C. I'm going to submit C now just to check and make sure that's correct, and C was the correct answer, right? So, again, I have my notes here. I can see it. You know who you are. You know where you fall. I'm going to crunch these, and I have to do this, because if I don't honor what I said I'm gonna do, then you don't take it serious, right? And so this is serious, because if you rack up unexcused absences too many, you can get booted. We're gonna take your money, and you may or may not be able to get back in the course, which, again, you don't want to be in that boat. So you want to take these things serious, right? Because, again, if you rack up too many unexcused absences, you're gonna get booted, and you're gonna waste your time and money. And I'm really trying not to do that, but I can't let you guys be so idle. Okay, so let's go to question number 11. Let's go to question 11. Then we're going to have to figure something else out. So question 11, okay, we got our y-intercept, and then we wanted the graph. If we did the leading term test again, the leading coefficient is positive, so it should go up to the right. So that means it can't be C, it can't be D, right? It can't be C or D. So if somebody's putting E, that's that person that's putting E, that's the main reason why I'm making this stuff accountable. So because I want to make sure that that person is not getting credit, because that's a waste of time. That's a joke. There's no E. So you can put that, but I'm going to mark you as absent. Right? That's the very reason why I'm doing this. Just FYI. So it can't be C, it can't be D. And then the leading coefficient. Okay, so the leading coefficient is positive, so that means our graph should go up to the right. And then the degree of the polynomial is odd, so it should go down to the left. So the answer should be A. I marked A. I'm going to submit A and check the answer. A is correct, okay? So that was that one. Again, I have my notes here, and I'm going to pull this data and give attendance based on the data. And I'm only looking at the ones that we did together, right? So if I submitted an answer, I know that's one that we did together. All these others, I'm just going to ignore them. Let's see. What's next? Are there any others? Okay. So this was question. So we didn't have that many, right? So you know that if you got 50% or not. Let me see how many did we do together. So as I scan, let me see. As I scan, what question was this? Okay. So 1, 2, 3. I only got 3. It's only 3 questions. So I'm gonna go through the data, and those 3 questions that we did together for the multiple choice, I'll make a decision there. Right now, it's like you're gonna be at my mercy if you don't have. So you have to get at least 2 of the 3 correct to get attendance credit. So if you didn't get 2 of the 3 correct, then you're gonna be at my mercy. And again, I'm doing this. I kind of doing this specifically for the people choosing like random stuff. It's like, but again, in hindsight, now I'm thinking like I know there was at least one student that thought that we had to submit all of them, so that could be that student. So then that's okay. And again, this is why I have to keep my mood kind of like chill because I get petty. I'm like a little girl. I know it's dumb, but that's my intuition, and that's just how it is, But again, if you're doing what you're supposed to do, then I'm not going to come at you like that. And if you're not, then I'm going to try to calm myself down and try not to come at you like that. But then if I get the sense that people are kind of jerking me around, then I'm like, okay, you know what, I'm good. I'm gonna just like boot the person or whatever. But again, my job is I'm going to try to keep myself calm and I'm going to try to be gentle and not stiff people. But again, it's imperative that you take this stuff serious, right? When we're doing these polls, you got to do your best, because now this gives me feedback. I can see that it's not, you guys need some help because it's not so obvious, right? So some things to kind of keep in mind. One, I do encourage you all to do a group meet. I don't know if you can work with a classmate or not, right? But that's a great idea, especially if you have a brother that like gets it and is willing to kind of sit down. So each one teach one. I think that's a fantastic idea. That's honestly how I learned a lot of this stuff. When I was a student at Morehouse, I worked in Archer Hall for work study, and that's when I did all my homework when I was at work. So I just sat at this desk. When people come in, I check the IDs. I look up, they show me ID, they're good to go. I sit back down. And so I'm already sitting, I'm getting paid to sit at this desk for hours on end. I might as well do my homework. And so by the time I got off work, I was already done with my homework. And when I got on the test, a lot of times the test was the same thing as the homework. They just pulled random questions from the homework. So as long as I did the homework, a lot of times just doing the homework is enough to get it, right? But if you don't do it or you shirk it off, then you're really just wasting your time. And we're doing our best to make this constructive for as many people as possible. Everybody doesn't make it, but we try to get as many people through as we can. Are there any burning questions? So I'm gonna sit, I'm gonna decide how I'm gonna do this today. But you got to be careful. You get 3 strikes essentially, and you're out, right? And you want to have as much cushion as possible. Okay. Let me see. So this week we just wrapped up section 2.2 of polynomial functions. Next week is going to be section 2.3, whatever that section is. I don't know the topic off the top of my head. You don't have to wait on me. Anything that I want to say live is already in the recordings. You can actually watch those pre-recorded lectures. It's the same examples, essentially the same delivery. You can go ahead and do those homework and just, and then, so next week is 2.3. And then the week after that is exam 3. Yeah, we're going into exam 3. Okay. Okay, so all right, gentlemen. So if there aren't any other burning questions, we got done a little bit early. We're gonna go ahead and end the session here. And from one beautiful mind to another, have a great weekend, and we'll meet back on Monday, same time, same place, for the next installment. Good luck, everybody, and take care. Peace. Take care. Chat looks good. Let me check the chat real quick. Okay, cool. Okay. Oh, I forgot to tell you. Is anybody still here? Are you guys still here? Let me see. There's a few people here, so I'll go ahead and say it. Maybe you guys can relay the message. I'm not opposed to you guys putting the answers here. If you guys want to work together, like when we're doing those, if somebody wants to put it in the chat, you can. I'm not gonna work that. Yeah, you don't have to select everything. Which number was the last question? Cool, that's okay. Right. So yeah. So if anybody's still listening, When we're doing these polls, if you want to put your answer in the chat for others to see, that's okay. It's not really a competition. It's really more of a collaboration. It's just how quickly do you guys decide to work together, right? The sooner you guys decide to work together, the better off you're going to be as a collective, right? I don't really believe in competition because that all that happens is create what we're experiencing now. And if you want to maintain whatever you're experiencing in society now, then you do competition. But if you want to see everybody get ahead, I believe in cooperation. So, anywho, all right, guys, that's it. Have a great weekend. We'll meet back on Monday. Good luck with everything, and take care. Peace. All right, all right.